Okay, today our topic is sedimentation analysis. Sedimentation analysis, whenever the particle size is less than 75 micron of the particle size, then we can go for sedimentation analysis. Why? If the particle size is less than 75 micron, we can go sedimentation analysis is the particle size, whenever the particle size is less than 75 micron, it cannot pass through the sieve because the particles are which are lesser than the 75 micron having the particles are attractive forces on the particle. So due to the attractive forces, the particles are not sieved through the gap between the sieves. Okay, so for this we have to go for sedimentation analysis. In the sedimentation analysis, the sediment analysis is working on the principle of Stokes law. According to Stokes law, the Stokes law means స్టోక్స్ లా మీన్స్ ఏంటంటే ఒక పార్టికల్ ఇది ఇతను ప్రిన్సిపల్ ఏంటంటే మీరు ఒక వాటర్ తీసుకోండి. ఒక వాటర్‌లో పెద్ద కంకర రాయి ఎయండి. వేయగానే అది ఫాస్ట్‌గా వెళ్ళిపోతుంది. దానికంటే ఇంకో చిన్న రాయి ఎయండి. స్లోగా దిగుతుంది. ఇంకొంచెం చిన్న రాయి ఎయండి. ఇంకా స్లోగా తిరుగుతుంది. అదే ఇప్పుడున్న మన వర్షాకాలంలో ఇప్పుడు మున్సిపల్ వాటర్ వస్తాయి కదా! ఆ మున్సిపల్ వాటర్‌తో మీరు గనక ఇప్పుడు పట్టిన మున్సిపల్ వాటర్ రేపు మార్నింగ్ చూడండి. ఫస్ట్ లైట్‌గానే మంచిగానే ఉన్నట్టుంటాయి. రేపు నెక్స్ట్ డేకి చూస్తే మీకు బాటంలో చిన్న పార్టికల్స్ ఒక లేయర్ కనపడుతుంది. ఓకేనా? అంటే దాని అర్థం ఏంటి? పార్టికల్ సైజ్‌ని బట్టి దాని యొక్క వెలాసిటీ ఉంటుందని అర్థం. ఓకేనా? ఎప్పుడైతే పార్టికల్ సైజ్ ఎక్కువగా ఉంటే దాని వెలాసిటీ ఎక్కువగా ఉంటుంది. సో ఇక్కడ డైరెక్ట్‌లీ ప్రపోర్షనల్. V is directly proportional to. So according to this Stokes law is given the sedimentation analysis process. So ఓకే. ఆర్ యూ అండర్‌స్టాండ్? సో ఎప్పుడైతే పార్టికల్ సైజ్ ఎక్కువగా ఉంటే దాని వెలాసిటీ ఎక్కువగా ఉంటుంది. సో అంటే ఏ పార్టికల్‌కైతే వెలాసిటీ ఎక్కువగా ఉంటుందో దానికి సైజు ఇంతుంటుందని ఇతను డిసైడ్ చేశాడనమాట. ఆ విధంగా మనం పార్టికల్ సైజ్‌ని ఫైండ్ ఔట్ చేయొచ్చు. ఎందుకంటే 75 మైక్రాన్ కంటే తక్కువ ఉన్న వాటికి సీవులు లేవు కాబట్టి మరి ఏ పార్టికల్ సైజ్ ఎంత అనేది మనం ఫైండ్ ఔట్ చేయడానికి ఎటువంటి డైరెక్ట్ మెథడ్ లేదు కాబట్టి మనం ఈ సెడిమెంటేషన్ అనాలిసిస్ చేస్తాం. సో ఈ సెడిమెంటేషన్ అనాలిసిస్ ప్రాసెస్‌లో ఏ పార్టికల్‌కి ఎంత వెలాసిటీ ఉంటుందో దాన్ని బట్టి పార్టికల్ సైజ్‌ని డిసైడ్ చేశాడన్నమాట ఈ స్టోక్స్ లా. సో ఇతను దాని ప్రకారం ఏంటంటే ఈ స్టోక్స్ లా వెనెవర్ కన్సిడర్ దిస్ ఈస్ యాస్ ఎ సాయిల్ పార్టికల్ like solid particle. The solid particle treated like as a sphere particle. Whenever this particle is flowing through a liquid, so it initially gains its maximum velocity and due to the under the action of gravity. So due to the under the action of gravity, initially the particle down it reaches to down very fastly. After the initial under the action of gravity, so after the some time it gains its buoyancy force, which are acting on the force of the buoyancy force upward on this particle, and also another force which are acting on the soil particle is drag force. So due to these two forces and due to the gravitational forces, this particle reaches at a certain velocity, at a constant velocity after a some time. So the constant velocity is known as terminal velocity. Okay, once again I'm repeating you. Whenever the sphere solid particle flowing through a liquid, initially it reaches a maximum velocity under the action of gravity. So due to this weight of the particle, after some time, due to buoyancy force and drag force which are acting on this particle, so which are opposite to the under the action of gravitational force, at a constant time it gains its retards its velocity. At a constant velocity it gains its constant velocity. That velocity is known as terminal velocity. So by comparing the summation of upward forces equal to summation of downward forces, here the downward force is the weight of the particle, here the upward forces is equal to buoyancy force and drag force. By equating these upward forces equal to downward forces, we can finally this type of equation we will come. So in this equation, so generally we can take velocity, we can identify velocity, we can obtained by velocity means generally we say that distance is equal to speed into time. Okay, speed into time, where speed means velocity. So in order to find this velocity, so common this one send to this side, so automatically get by. So where depth means height, so time means time. So therefore finally we got the velocity in terms of velocity. So this is the process in the sedimentation analysis. The Stokes law is considered like this way. Okay, next one. So next one, sedimentation analysis. In the sedimentation analysis, after the sedimentation analysis, we are going to in the in the future we go for pipette method and hydrometer method. In the pipette method and hydrometer method, we require soil suspension. So in order to require of soil suspension at that pipette method and hydrometer, first in this place we have to find how to prepare the soil suspension. So first in this preparation of the suspension, first initially take 50 grams of oven dried soil. Okay, take 50 grams of oven dried soil, not concentration of any water particles in the soil. So completely 50 grams, it should be absolutely oven dried soil, and it is transferred to a evaporating dish. Okay, first initially we take the soil and it is placed into an evaporating dish. After this evaporating dish, we have to add we have to add 100 ml of dispersion solution. Okay, we have to add 100 ml of dispersion solution. The dispersion solution preparation is like this way. First initially we have to add 33 grams of sodium hexametaphosphate plus 7 grams of sodium carbonate to 1 liter of water. Okay, so after this 1 liter of water, out of this 1 liter of water, we have to take 100 ml of water from 100 ml of dispersion solution to the soil only. Okay, not taken total 1000 ml of soil suspension. Just take only out of this 1000 ml suspension, you have to take 100 ml suspension to the soil. Okay, the 100 ml dispersion solution preparation is the 33 grams of sodium hexametaphosphate plus 7 grams of sodium carbonate. These two combinedly add to the 1 liter of water. So after preparation, we get to 1000 ml of suspension. This 1000 out of this 1000 ml suspension, we have to take only 100 ml of suspension to the 50 grams of oven dried soil. Now the mixture is warmed and gently about 10 minutes, like 30 degrees, 40 degrees temperature. The mixture is after this the dispersion solution is added to the soil. We can get the soil suspension. The soil suspension is warmed gently about 10 minutes. After the suspension is warmed, so now the suspension is taken into a mechanical stirrer. Okay, now the suspension is taken into a mechanical stirrer. In the mechanical stirrer, so a cup of mechanical stirrer, in this cup almost 3 by 4th of the cup is filled with the soil suspension, and to start the mechanical stirrer about 10 minutes. Okay, so like this way, the mechanical inside this jar, we have like this mechanism. So with this mechanism, so automatically it rotates in the vertical axis. So automatically the soil is uniformly distributed and uniformly uh, changes its all proportions. So after this process, now the suspension is after the uh, evaporating dish, after that mechanical stirrer, this soil suspension is taken into a 75 micron sieve. So why? Because we are using sedimentation analysis is less than 75 micron sieve. So in this process, just we have to the soil suspension is sieved through a 75 micron sieve. After the 75 micron sieve, is there any particle which are retained on the 75 micron is known as sand fraction. The sand fraction is again dry and it is taken to a fine sieve. Whatever the fraction which is passing through the 75 micron sieve is taken to a prepared method or hydrometer method. So this is the preparation of soil suspension which are used for the next coming prepared method and hydrometer method. So now this suspension is taken and making it to a 1000 ml by adding of water to the this suspension. Okay, this is the following steps. Generally we have to add the process the. Okay, first what we do, first take 50 grams of oven dried soil, then add sodium hexametaphosphate and sodium carbonate and 1 liter of water. Out of this 1 liter, just add 100 ml of soil suspension. After this soil suspension, take gently about 10 minutes, temperature at 10 minutes. After this preparation, after the warm preparation, now the transfer this suspension to a mechanical stirrer about to completely 3 by 4th of its filling in this mechanical stirrer. After the stirring about 10 minutes, then it is transferred to a 75 micron sieve, and whatever the fraction which is retained on the 75 micron sieve is taken into a oven tray, and then it is transferred to a mechanical what is we say mechanical sewer. So after this, whatever the fraction which is passing through the 75 micron is taken to and make it as a 1000 ml suspension by making adding of water of 1000 ml. So now this is 1000 ml suspension is used in the next process of pipette method and hydrometer method. Next one. Okay. Next one. if the soil suspension, okay, if this process is commonly for any type of soil, okay. But whenever the soil, if you take the soil having organic matter means any dead animals or dead particles like leaves, plants, like any roots, like if if the soil contains like organic matter, and also if the soil have calcium compounds like white particles, calcium, chalky soils, like if the soil contains like these two components, if the soil has these two components, we have to remove these from the soil also, okay. So first initially we have to remove from organic matter, this is one stage. And if we want to remove the calcium compound, we have another process. So combinedly we have generally two stages. Initially just we have to take 100 grams of soil in a beaker. So in 100 grams of soil, so just take 100 grams of soil in beaker and treat it with 100 ml of 100 ml of 20 volume hydrogen peroxide. So for in order to remove the organic matter, if a soil has organic matter like dead plants, dead animals, like if a soil contain like this matter, so we have to pre-treat it. So just we have to pre-treat it. So how we can pre-treat it? Just to take a 100 grams of soil. So after 100 grams of soil, we have to add 100 ml of 20 volume hydrogen peroxide solution. So 100 volume of 20 volume hydrogen peroxide. Next, after this adding of this 20 volume hydrogen peroxide to this soil, so next the mixture is warmed and not exceeding 60 degrees centigrade. So after this, after the preparation of this suspension, we have to mixture is warmed about 60 degrees centigrade. After this warming process, next we have to, after the whenever this heating of this suspension, automatically the gas is liberated from this suspension. So about మీకు ఎలా అంటే, మీకు ఉప్మా ఉప్మా వండుతారు చూసారా, మీరు ఉప్మా వండినప్పుడు ఉప్మా అయిపోయే ముందు లాస్ట్ లో బుడగల రూపంలో టుప్పుకొని లేస్తుంటాయి చూసారా, అప్పుడు అలా వచ్చినప్పుడు వాటర్ గ్యాస్ బయటకు వస్తూ ఉంటుంది. సో ఎప్పుడైతే అట్లా గ్యాస్ అనేది బయటికి రావడం ఆగిపోతుందో అప్పుడు మీరు దాన్ని కూల్ చేయాలి. Whenever the no gas is liberated from this soil suspension, so after this after no gas is liberated, then it is transferred to a any cooling place and make it a some separate time, and make the mixture is then cooled. So after this process we have to take the first step, okay. Okay, next step is, if the soil suspension has calcium compounds, whenever the soil contains calcium compounds, we have to follow this process. First, you have to take same process like this above step. First, initially we have to take 100 grams of soil. So 100 grams of soil to this soil, we have to add 100 ml of 0.2 normality hydrogen chloride. Okay, so take 100 grams of soil and to take about for this 100 grams of soil, we have to add 100 ml of zero point 0.2 normal hydrogen chloride to remove the calcium compounds. Whenever when we add 100 ml of zero point 0.2 normal hydrogen chloride to the soil suspension, automatically starts reaction. So after the reaction starts, it's completed automatically. Why how we can know the color of the mixture is changes, or may its color changes, or maybe bubbles, or may like all the process completely completed. After the whenever the reaction is completed, the mixture is filtered through a distilled water until it is free from acid. Like whenever the water is added to the suspension, it may change or color, or may like this color. So after this color of this suspension, we have to add water until it is free from the acid. So no extra color is appears in the soil. Completely we have to remove the any acid in the soil. So after the process, we have to place it in an evaporating dish and dry it in an oven. It will take a constant mass. Okay, so first we have to take 100 grams of soil. After 100 grams of soil, we have to add 100 ml of 0.2 normal hydrogen chloride. After this process, we have to, then automatically the reaction starts. Whenever the reaction is completed, so we have to add water to this suspension. So whenever the water is added to this suspension, automatically, so the automatically the color is goes out. Whenever the color is comes out from the soil, we have to take it in an oven and make it oven dried. Okay, this is the process generally followed in the suspension of the soil, whenever the soil contains organic matter and calcium compounds. Okay, so after this three process, we have to take this soil suspension into pipette method and hydrometer method. Next topic is theory of sedimentation. Okay, theory of the sedimentation. So this is also same like this already discussed in the last slide. So watch this paragraph or listen this paragraph. At the commencement of the sedimentation, at the starting of the sedimentation, whenever you take a soil suspension like before preparation, initially the soil particles are uniformly distributed. Okay, whenever the soil suspension is preparation, after the soil suspension is preparation, the soil particles are uniformly dispersed throughout the suspension. So in each layer we have different types of layers and uniformly dispersed. At the starting of the commencement, and particles of different sizes is same at all depths. Okay, here the particle is same, here also same, here also particle is there, here also. So at the starting of the sedimentation, the particles of the different sizes is same at a uniform at all depths, having different concentration of the different particles is same at all depths. Here also the particle is same, here also the particle is there, here also like the small particles are present at each layer, and also big size of particles are present at each layer. So at the starting of the sedimentation, if the concentration of the particles of different sizes is same at all depths and uniformly dispersed throughout the suspension. So yeah, after the in order to easy way, so after we have to take only small only some particles and represented as this way. So at the starting of the sedimentation, all the particles are same at uniformly dispersed and the concentration of the particles at each layer having the same at all depths. Okay, here also two particles, here also two particles, here also the concentration is same at all depths and also uniformly dispersed. Here also six particles, here also. So like this way. So it is the at the starting of the sedimentation. After the time goes and the concentration at the sedimentation is starting process, at the time of at the time it goes on, so automatically the larger particles are settles very fastly. The larger particles are settles very fastly compared to small particles and small particles and smaller than these particles, like this way. So already told that ఎప్పుడైతే పెద్ద పెద్ద కంకరాలేమో చాలా ఫాస్ట్ గా దిగుతాయి. ఈ స్టార్టింగ్ లో ఉన్నప్పుడు మనం అన్ని పోసినప్పుడు ఒకే దగ్గరలో ఉంటాయి, అన్ని ఒక్కొక్క దగ్గరలో అన్ని ఉంటాయి. ఎప్పుడైతే స్టార్ట్ చేయగానే వెంటనే సో ఎక్కువ ఎక్కువ పార్టికల్స్ అనేవి చాలా ఫాస్ట్ గా దిగుతుంటాయి. స్మాల్ పార్టికల్స్ మాత్రమే చాలా స్లోగా దిగుతుంటాయి. ఇంకా స్మాల్ పార్టికల్స్ ఎప్పటికో దిగుతాయి. అందుకే మనకి మున్సిపల్ వాటర్ ఉన్న వాటర్ రేపు పొద్దున్న చూస్తే ఇప్పుడు అప్పటికప్పుడు చూస్తే ఏమీ లేయర్ బాటమ్ లేయర్ ఏం ఫామ్ అవ్వదు. నెక్స్ట్ డేకి ఫామ్ అవుతుంది. అంటే so due to this particle size of the particle size, so based on the particle size and based on the weight of the particle, some particles are reaches very fastly and some particles are reaches very slowly. Okay, like this way. So initially we have to take the at the starting of the sedimentation, we have to take this some amount of water in this suspension through a hydrometer method or pipette method. So initially the soil suspension weight it can be gained by mass of the particle per ml at a depth of He at time t. So 100 mm or 20 mm or 30 mm. So initially we have to take any effective depth He height at He height. We have to take the mass of the particles per ml at a depth at time t is equal to 0. Okay, so after the particles sedimentation is process at a time whatever the time we are taking, so like 15 minutes or half an hour or 1 hour 2 hours, at the time of 2 hours or at the time of 30 minutes, whatever the time you are taking. So now that again same whatever the depth is here is taken, same at the same depth we have to take the soil suspension from this soil from this soil suspension and take it and measure this mass, and the mass of this particle is per ml at depth He time to be taken. So this these two masses can be calculated by taken by pipette method or hydrometer method. So by taking these two steps at the starting and at the ending, automatically we can get the percentage finer by, so initial mass of the soil suspension weight by present mass of the particle of the soil suspension weight at that time into 100, we can get the percentage finer. After this percentage finer, we can also calculate the particle size also. How we can get the particle size? Here we are taking at a uniform depth. Suppose for example at 200 mm or 20 mm, each time we are taking this particle size at a depth of only 10 mm or 100 mm, like this way at the time 0. So at the time 0, automatically we get the 100 by 0, we can it's transferred, we can get like this way we can find out this particle size. Okay. ఓకే. సో, అంటే ఏంటంటున్నామంటే అండి, ఇనీషియల్‌గా అట్ ద సాయిల్ సస్పెన్షన్ స్టార్టింగ్‌లో చేసినప్పుడు, స్టార్టింగ్‌లో సాయిల్ సస్పెన్షన్ చేసినప్పుడు ఏమవుతుందంటే, సాయిల్ సస్పెన్షన్ స్టార్టింగ్‌లో మనం పిపెట్ మెథడ్‌తో గాని, హైడ్రోమీటర్ మెథడ్‌లో గాని, ఈ సాయిల్ సస్పెన్షన్‌లో ఉన్న కొంచెం వాటర్ సాయిల్ సస్పెన్షన్ కొంచెం తీసుకొని దాన్ని వెయిట్ మెజర్ చేస్తాం. సో, అలా స్టార్టింగ్‌లో వచ్చింది ఎంఎస్. ఆ ప్రాసెస్ స్టార్ట్ అయిన తర్వాత మనం 20 మినిట్స్ కానీ రకరకాల టైమ్స్‌లో మనం తీసుకుంటాము. నెక్స్ట్ మెథడ్‌లో క్లియర్‌గా చెప్పుకుంటాము. సో, ఒకానొక టైంలో మనం తీసుకున్న సాయిల్ సస్పెన్షన్ తీసుకొని మళ్ళీ దాని వెయిట్ మెజర్ చేస్తాం. సో, ఎట్ ద టైమ్ తీసుకున్నప్పుడేమో ఎండీ అవుతుంది. ఎట్ ద స్టార్టింగ్ తీసుకుందేమో ఎంఎస్ అని మెజర్ చేసుకుంటాం. సో, స్టార్టింగ్ ఆహ్, ఆహ్, at the starting time by at the particular time by starting time we can get the percentage final. So అదే నెక్స్ట్ మీకేం చెప్పానంటే పార్టికల్ సైజ్ ఫైండ్ ఔట్ చేయాలంటే ఎలానో చెప్తున్నాను. సో, పార్టికల్ సైజ్ ఫైండ్ ఔట్ చేయడానికి ఎలా అంటే ఇగో ఇక్కడ పార్టికల్ సైజ్ ఫైండ్ ఔట్ చేయడానికి ఎలా అంటే, సో, ఇక్కడ హెచ్ఈ ఎఫెక్టివ్ హైట్ ఫర్ ఎగ్జాంపుల్ 100 ఎంఎం, 20 ఎంఎం తీసుకుంటాం. సో, వెన్ వి టేక్ కాన్స్టెంట్ హైట్, సో 20 ఎంఎం, 100 ఎంఎం ఎట్ ఎ టైమ్, so we can get the velocity. So after this velocity substituted in this above equation, automatically we can get this particle size. Okay, from the percentage finder we can also find the particle size whenever the taking of an effective height particular time, automatically we get the velocity. The velocity is substituted in this equation, we can get the particle size. G is constant 9.81. Specific gravity of particle is taken as 2.65 to 2.8. Generally we are taking 2.65 or 2.7. So density of water is 1000. This is the coefficient of viscosity of water. Okay, so like this way all information is constant, only particle size is varied. So we can ultimately we can find out this particle size. Like this way we can find out the particle size by using sedimentation analysis. Okay.